Today we're looking at Lesson 3 of the Algebra 1 curriculum, and today is a very important lesson. Of all the things we do or have done so far, I would say this is probably one of the most important because it's introducing some notation and some concepts that are going to be in this course for the rest of the course. So it's kind of heavy on the new features in Desmos. I mean, the features they're going to be using. So spend a good bit of time on that. I do have this scheduled for 2 days in the curriculum or in your guide, but use your best judgment. I don't think I would skip much of this. I do think it's important enough to take the time to do this well. So the first thing we're going to do in this assignment is look at these slides. The first thing we have here is a function. And so they've not really seen function notation. This is kind of their first, I guess, their first real experience with it. And they're going to basically use an inquiry kind of method of getting used to it, like learning it. So I'm going to give them functions that are in function notation, have them play around with it and explore and see what is going on. So here we have Cheyenne, and she is paid according to a function. She gets an hourly wage, and she also gets an extra amount of money for her travel. So they will click on this link, and when they do, it's going to open up a graph in Desmos. So here we have the graph. It's completely done, so they have lots of stuff to look at in here. I included a table and equation, a restricted domain, and a few function values. And then they are supposed to look at this and try to make sense of what's happening. So this is where I would circulate through the room as the kids are working. I seat my kids in teams of 3 or 4. It just depends on how many kids are in the class, but at least in pairs. I try not to let anyone work alone. Occasionally, I had a neurodivergent student once that absolutely could not work with another person. She would kind of flip out if you sat her next to somebody, so I did allow her to work alone. But that's the exception. I'm putting these undefined things in here because I do want to talk about those. Like, why do you think this is saying undefined at 200? What's going on? So I'll keep referring back to the situation with Cheyenne. Now, fortunately, I had a television in my classroom, and I was able to display the slide while they were exploring, and I could keep pointing at it and referencing that slide that had the scenario with Cheyenne. I'll go, what's going on with Cheyenne? And so they would figure out that her rate was $35. I guess this was hourly rate. Let's look at it. Yeah, it says she earns per hour. So they eventually are going to get to the point, I hope, at this point, that the 35 is the slope or the rate of change in the graph. And then the 120. Now, coming into Algebra 1, all of these kids have worked with slope-intercept form a lot, but ironically, they don't really know much at all about what it's doing or what it means. So this is kind of forcing that issue and getting them really comfortable with the form. And so the concept of domain from 0 to 180, I'm probably not going to expect them to use the word domain in this situation yet, because that's not really the topic that we're hitting on the most today. But if you want to go over domain in this situation, would be 0 to 180 hours. So she must work 180 hours in a month, according to this. The -2, why is it saying undefined? Well, her hours are never negative. That's impossible, so of course it's undefined. And then these are values at 10 hours and 160 hours. And those are actually showing up in the graph itself. You can see it here. They can even click on this graph and see what these points are. If they click in between, like 160 is actually in the graph here. If you click in between, they can drag along the graph. So you might just want to show them some of these cool features. These are in the table as well. So at 160, the value is 5,720. The domain is restricted with these curly brackets. They'll be doing all this themselves later. So this is just kind of a first peek at this. So I don't expect them to have everything nailed down. They probably won't even answer all these questions correctly, but it will get them started. So the next slide will be another scenario. This time they are given a graph, but less is in here. So I'm asking them to click the link to get to the graph and then add labels to the graph to represent this situation. They're given 2 specific points in the graph. Some of these kids are going to come back over here and look at this one when they're doing this one to try to make sense of this. And I actually hope they do that, because I'm trying to get them to be a little more independent and looking for things. Another reason I see them in teams is one kid will notice something right away and another kid has no idea what's going on. I mean, that's normal, especially with 9th graders. So I do like to have teams working together, and then I'll ask other members of the team to answer a question to assist a student who may be struggling with one of these questions. When they click on this, it's going to take them out to the Desmos graph, and very limited graph this time. Notice there are no labels. So this is where I introduce them to the graph settings. It looks like a wrench in the upper right hand corner, and then I would have them label the x-axis. They can put X, but what does X represent? In this case, it was Braden babysitting per hour. So you would put hours here, or time in hours, or something like that. And then the Y value, they can put Y. In fact, I always tell them Y is always an option, but you can also put the function notation if you want to, and that would be his pay. So I'm just going to change this. Instead of Y, let's do B of X, and this is Braden's total pay, or pay for babysitting. You can put as much detail as you want, but just something like that. So once they do that, then they can export the graph. So I'm teaching them how to do that. This is where they're first taught. I need to fix my X label because I didn't put hours, did I? Let's put hours in there. Alright, let's try this again. Export image, and this looks good. I still don't see my hours too good, but when they copy this image or they download PNG, if they're on a Chromebook, my kids normally just copy and paste. So they'll copy it from right here and paste it onto their slide, and we do this all the time. So getting screenshots and such are there is a pretty common thing for them. So type Control V to paste on the slide, and it'll just pop right in here, and miraculously it landed where I want it. Sometimes it knows. If not, they can move it around. They can resize it. They can crop it. So we play with all these features a lot. The first few weeks of school, we're doing this stuff almost every day, because I want it to be something they just do on their own. When I ask them, show me a graph of that, they'll run to Desmos, make the graph, come back, put it in. I don't have to tell them after they've done this a few times. So there's the graph. Now I can answer some question. What was 0 of 15, or 0 15 and 0 hours? He earned $15. Well, that would be that amount he got up front probably for his gas money. And then for 3, he got 45. Well, what does that mean? Well, I guess in 3 hours he earned $45, and that included that gas money. To get the slope of the graph, the change in Y divided by change in X, you could say it went up from 15 to 45. It went up $30, and it took 3 hours. So it went up approximately, or it went up exactly $10 per hour. So that was his hourly rate. So right here, you're kind of seeing where your kids are with rate of change, slope, finding slope from a graph, interpreting the slope. Again, all things they should know, but don't get mad at them, because they won't know. I don't care how good they are. This is a weakness across the board. I've seen it for 36 years. Kids have been taught all this, but it's not sticking. So spend time talking about what it means, not just how to find the slope. Some of them can do that, but then what does it mean in this context? The next slide is... This is where I introduce delta, the delta Greek letter. I use it a lot. It is kind of a pain to use, I'll be honest, because it's hard to get that symbol anywhere, especially in Desmos. But I try to make it easy for them to use. And the reason I do it is I want them to think of a rate of change when they think of slope. I don't want them thinking of a formula as much as just the concept, the rate of change. So I use that throughout algebra. Every time we come across slope, those symbols pop up. Well, here we have a graph, and they're to tell me some things about it, what is happening. So we may talk about it as a whole class. I may have teams volunteer. And as you can see, the values are decreasing. And then you have labels here that kind of tell you what's decreased, the amounts decreasing as they purchase something. So we could talk about what are they purchasing. Those are all subjective. We don't know, but we just know there's some money here and the value of money, or the amount of money, is decreasing. So they'll evaluate these expressions in this context. So 0.45 would be the starting amount. 3.30 after 3 purchases, they're already down to $30. And then after 9 purchases, they have no money left. So they could use any kind of language to say something like that. I'm basically trying to get the real world meaning out of those statements. And then down here in the bottom, I put lots of show notes. I have some on the other slides as well. I want them reading those notes. So these are for students, not for the teacher, that they are important. So refer to those notes often. Say, did you read your notes? What is this symbol? Oh, it's delta. Well, what does it mean? It means change in the amount over the change in purchases. So the amount's decreasing each time they make a purchase. That is the slope of the graph. And so anyway, I give them some little notes at the bottom. It's kind of like definitions. I'll sometimes pop those into the show notes. And then finally, we have here, they're going to create something. So I've kind of got them started, and this is how I do it. I give them a scenario, and maybe I work out a lot of it for them, but they can choose something on their own to put in there. So in this case, they are given a function, but I'm not telling them how much they're making per widget. They got to figure that part out. So we click on the graph, and you'll see it's kind of set up for them, but these little triangles mean there's some errors here, and that's because it needs more information. So they will change this to whatever they think they ought to earn per widget. Well, maybe they think they should earn $5 per widget. Or they may say, that's a pretty lousy shaped graph. I think I like having $20 per widget. Oh, that's a little better. And then some kid, okay, no, I want $100 per widget. If they do that, they're going to want to adjust the graph to see the highest point. So, they can use their best judgment. How about $50 a widget? Oh, that looks great. So maybe $50 is my going rate, but they can play with this and use whatever they want. Once they do that, they can adjust the window of the graph or not. They don't need to if they can see everything. And what's cool is it will plug the values in and give these outputs automatically once they put a number in here. So they're not having to do too much. Literally, they're just changing one number, but just having them do that, they have some control over what the output is. And then they'll take their function graph and put it over here. I do ask them to do a screenshot of their equation. So this is the first time they will need to learn how to use their Chromebooks to do that. And if you don't know how to do that, all you have to do is ask your students. In fact, you should get student volunteers to demonstrate, because they love to do that, and they can teach the class. They can even go group to group and show each group how to do it. So it's kind of a fun activity. Kids know these Chromebooks, usually better than their teachers. So if you're on a Chromebook, laptop, whatever device your kids are using, let them get involved in helping each other learn these features. Screenshot is on laptops, usually one of those F keys, so you can usually find them up there somewhere. Or you can use a snipping tool if you're using a Windows PC kind of computer. But they'll know. You don't really have to teach the whole class. Just get some student volunteers to make this happen, and then you'll be doing this all year too. So we want to make sure we know how to screenshot. And then they're going to describe what these values mean. Well, of course, I don't have the outputs on these because I don't know what they chose for their slope. So anyway, and then down here, don't forget to refer them to these show notes. Analyze this function. What does this mean? What's the slope? So this is going to take the bulk of your class the first day, for sure. I would spend the most time on it. You can always cut out or cut back on the second 2 parts. Function Carnival 1 is one of those play kind of things where they may or may not get everything out of that one. But Function Carnival 2 is super important. So I'm going to show you both of them. So here is what I'm working on. I did put 3 days here. I kind of keep changing my mind, but you can decide if you need 3 days. This is Function Carnival 1, and I've given you a link out to this activity. It's very fun. It's very similar to Turtle Crossing, So they're going to click this and describe what's happening. And then you're going to actually sketch a graph of what you want him to do. You'll get some crazy stuff here, so just expect it. Their goal is to try to match, like their guy needs to match the one you see there that's kind of faded out. So I didn't do too good, but they can click X here and try again. So the next challenge, you're going to create a graph and you're going to try to make the little green car match the one that's there, or you could make it not match it because the green car actually crashed, I believe. So anyway, here's some questions about it. We have a Ferris wheel. We're looking at the green car on the Ferris wheel. We're trying to describe what is happening. You have several scenarios here for kids to play with and get a feel for. And then finally they can create their own scenario. Next we have the hot dog challenge from Robert Kaplinski. This is a classic. It's a commercial, and basically it's those famous eating contests where they come in and eat hot dogs. Him and Sonia is the name of the woman. And it's kind of ironic because he's in the news, I think, for retiring from the sport. I think he's done some damage to his body doing this, but anyway, it's a funny thing and it gets kids involved. I had them make poster paper and make posters of this. So anyway, but they eat the hot dogs and there's a whole bunch of questions to ask. I really only did the first part of this one, which was how many total hot dogs did they eat, you know, round by round. Like how many did she eat at first, then how many did he eat, and so forth. And so we made 2 tables, they graphed them, we talked about it. You could introduce function notation, so you could do maybe a K for Kobayashi for his, you could do S for Sonia, or T for Thomas. I mean, however you want to label it. They could use function notation if you want to get into that. I did not. And then they just have some questions here to answer. And then they're trying to figure it out. Now, he does give you the answers to round 1. This is round 2. Actually, it's a quadratic, so I definitely probably wouldn't do that this early. I would stick with the linear part. You could revisit this later. They show some student work here, so click on it and read through. These are some actual student answers. They're kind of cool. So anyway, it's a great activity. Highly engaging, and it's a great team activity to do early in the year. The next activity, this one's another pretty important one. This is Function Carnival Part 2. So of the 2, I really think this one's more important. It's up to you how long you want to spend on Part 1, but Part 2, we're getting into the notation. So this is new for this course. They do revisit this activity. This is a graph somebody made of somebody being shot out of a cannon. And then so what I'm going to do is add a label. That's that label. What it's doing is it's showing this point as it goes along the graph as he's moving. And then finally, this one I didn't understand at first myself. Well, what it's doing is it's got 3 points in here. So what you're supposed to do is drag these around. If you don't, you'll only have 0, 0 for all your points. So be sure you tell them to move these out. You have a total of 3 points. You can put them anywhere you want, but just don't keep them all at 0, 0. And then they can explain what those numbers represent here. And then here's where the function notation comes in. At 2.8 seconds, the height was 32.144. And so they're talking about function notation again here. So we're reviewing again what we've just done. And then after 8 seconds, they're supposed to type in f of 8 seconds equals the height. And then they can share it. And they'll be able to see each other's responses there. So that's when you would intervene if a kid's not able to make sense of that. And then they get to pair up these scenarios with the function notation and the points in the graph. So they have all 3: words, graphs, and function notation. This would be probably my, I guess, my check or my assessment to see where they are at this point. So if they've already done the slides, they've already worked with function notation through to this point, we should start getting an idea of who's getting it and who's not, and who do I need to step in and talk to. All right, the next activity is a graspable math activity. I'm probably going to pare this one down and actually include some scenarios or context in here. But I did want to show you the one I already created so you can get an idea of how this works. Here we have a function, and here we have a value of x. You can drag the 4 or the x into the parentheses to evaluate the function. So we're going to do that, and then you can take a value of f of x. You would grab the f, be careful, and put it over here in place of that, and it will change it to a 1, and then they can solve it. I haven't created this yet, but I am going to create something that has a scenario with it. You can click this arrow to add more space if you want to scroll down. But the value would be -1. And you can reset if they mess up. And then, so I have several canvases here. Let's see what we got. In this one, I take the value of x and put it in here. It'll change both. They can simplify it. And then it says, notice the difference. You know, one has a plus, one has a minus. What's the output going to be? So they just click on these to simplify them. They'll learn order of operations if they don't already know them, because it will only let them make legal moves. They can't, like, subtract. If it's, like, I can't subtract this. If I try to, it wouldn't let me. Let me do another one. I'll show you. Let's see, take this x. Now I can't put it here, or I could put it here, but that's not where it goes. I want to take f of x, so grab the f, and it'll pull the whole thing, and I want to replace that with a 6. Now if I try to add this, see, it's going to shake. I can't combine terms that are different, so it will let me solve. And there's multiple ways to solve. Oop, it didn't like that. So the x is 6. So you get the hang of it. I'm not going to do a lot of these. In fact, I broke my own rule here, because look at this. I did way more than 5. I'm not supposed to do that. What is the value of f of 5? So here they would not have the canvas. I will probably give them a canvas. Here's a table. Here's a graph. But what's missing is the actual scenario. So I'll change this. I'll do it better, and I do want to give you something in graspable math, but I want to show it to you. She's evaluating, place her marker on her mistake. Well, it looks like she replaced her x with -2, so that looks right. When she multiplied here, the mistake was right there. She should not have a -6. She should have a +6. So when you click, it'll turn green, and if not, they can do it again. And that's it. So anyway, this is Graspable Math. Cool program. I do use it a lot, but mostly for the algebraic portions, particularly when I'm introducing something new. Okay, finally we have a lesson in illustrative math. This is GeoGebra, and you have to evaluate functions, interpret functions in a context, quite a few questions. You might just want to do part of this, but it's pretty interesting. These are not self-checking, so probably want to have kids share out or do something. I don't know that I'd want to come in here and do self-checking or have to check all this, but maybe go through it with them at the end to check their answers. But this is a cool activity, multiple scenarios, real-life scenarios with function notation. So that concludes this lesson. As you can see, it's got a ton in here. It is one of these that's going to spread over several days. Break it down however you want and do it in any order you want. You may start with Function Carnival 1, something kind of fun and showdown, and then do the slides. So it's up to you the sequence, but I do encourage you to let them work in teams to learn some of their calculator and technology skills in teams, and then explore the new software Graspable Math and what it's capable of. It's a fun lesson. I really enjoy all these parts of this lesson. If y'all have questions, talk to me on Twitter, and y'all have a great day.